please fill the blue sheets.
Very important protocol. That's true. Very well.
But actually, the room is kind of strange. I was hesitating, pushing this escape bar. You know, it says this is the room. You mean this is a way to enter the room? It's kind of strange.
People in the room can prevent the gas. It's like the push.
Good start.
Okay.
No, it's better than that. Hi, good afternoon. Thank you for joining Roll. And we're going to start the meeting now. So, because we have a tight agenda. Okay, please aware of the note well. This applies for all the IETF activities. Thank you to Dominic for 10 minutes and Peter for the script. This is our agenda. So I hope all the authors are here. Okay, our milestones. We can see that we have some delays with some. So we tried today to discuss about that and how can we improve them. We need like co-authoring and people that are willing to do work. Okay, this is the state of the actors internet draft. Our open tickets that we have to address. The ready internet draft, both is going to be presented today and one is going to be discussed today. Okay, be aware that we have IPRs for to draft. So about this, old draft. Okay, about this draft, those are the, thanks to the Mike Hurd for doing comments. Those are the slides of past IETF as well. So we are updating several standards related with the REPL option type that we have to update. So we propose to update to 00, the REPL option type, to indicate that when an IPv6 node finds an hop by hop header and doesn't understand, it should skip that option and keep processing the packet. So that causes a flag day between the when there is the network that handles 63, the previous REPL option type, and the new one. So we propose, as was suggested the last meeting, use a total configuration option. But we propose to use a flag on that configuration option. But there are like 3 questions or 3 topics that I want to discuss about this document because it's taken so long. Like if we have to handle this solution in this draft or we have to make a new draft. It's a problem that we have to solve in this document. That is one question, if you agree with that. Yes. So I don't know, it's a question for you if you think that we have to like handle in this document or do a new one. Yeah, Pascal.
So the various deployments I'm aware of, including the ones that my company participates to, they don't deploy REPL. They deploy something like YSUN or wireless HART or something like that. So there is a consortium of sorts which picks a number of features of documents of RFCs, IEEE specs, etc., and says, out of those specs, I'm going to do this. I'm going to package that, and then I'm going to do some certification to prove that you actually do what we say you do. And so they are the guys who decide, I'm going to use this particular document, I'm going to use RFC 8138, etc. And when they release a standard, which has a certification package, that is a flag day, right? And that's the flag day we're talking about. I don't see someone just saying, oh, I'm going to play with various implementations of REPL of various sorts without, some kind of a certification body which packages something and say this is interoperable. So I don't really mind about the flag day. I mind that a certification of some form at some point decides to go to this new setting, to go to 6-layer H and a number of other things, which individually each of them create a flag day. Even going from IEEE before 2015 to 802.15.4, 2015 creates a flag day. I mean, not everything creates a lot of flag days. But a certification body says, oh, you use IEEE 2015, you use REPL plus amendments, blah, 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 and we'll have a certification package for it. And that solves this problem. It's not this document which will solve it. Don't worry.
Okay, we're going to handle that here. Rahul?
Rahul Jadhav from Huawei. So, so basically, the problem that I see is with regards to the upgrade when the upgrade happens. So it is quite possible, even though the certification body or YSN accepts this particular flag, or this particular decides to use this particular RFC, still there will be an upgrade cycle, in which case this would be needed. So what I would really like to see this flag proposal to be kept in. I mean, frankly speaking, I don't have a problem keeping this flag in a separate document or in the same document as well. But what I'm trying to say is, even if the certification body accepts to decide, it's not like all the nodes are going to get upgraded at the same time. It might not be possible. So there might be few nodes in the network which might be left with the previous settings, and then they come up later. Yeah, right. Thank you.
So if you're talking about backward compatibility within one of the standards, yes, this problem may arise. And basically, if your question is there a backward compatible text that's needed to say, for instance, if I'm seeing the old flag in a packet, I put the new flag instead, or not, or something. Or you say, the network cannot have backward compatibility. Yes, you could spell that. Just backward compatibility section is useful. I agree with you, but flag day and what I'm saying, the standard is the standard that embodies this must specify how it works. So
Okay.
I still don't think it's your problem.
Okay, thank you. Who's willing to review the document? Okay, thank you, Raul. What else? Pascal, but you are the call. Someone else? Okay, thank you, Georgios. So please read it because it's in last call and we already have all these 24 use cases. So we update as well 8138. When they have to decompress, they have to use the new option. And okay, this is the use cases for reference. Okay, thank you. Next one is...
No, I still have a question. This
yes.
document is in working group last call. The working group last call finished about today, as far as I know. I have not seen any reactions on the mailing list, which disappoints me a bit, I must say. So please have a review. The document has been reviewed and repassed. I know that it has been happened quite a lot. Yeah, I know it. Nevertheless, we also have to go to 6 months probably before this.
Okay.
Yeah. So if you could read it, look at it, also including these 6 flag arguments, then it will be fine to have your arguments on the mailing list. Thank you very much.
Thank you very much. Raul?
Hello everyone, I'm Rahul Jadhav from Huawei, and this work is about, so it was adopted last IETF, and in the previous IETF there were some suggestions from Pascal, Michael, about the about not changing the existing bits in the DAO message, and primarily the updates are about in that particular context. So briefly, for people who are not following this works, the work is about optimizing the route invalidation procedure. So currently, in RFC, as per RFC for 6550, the proactive route invalidation happens. So if a node switches the parent, it still sends a notepad DAO from the previous path, and it's not optimal by design. So what we intend to do here is, in place, the common ancestor node detects that there is a change in the next hop, and it decides to send a new message. Previously, this we were calling it notepad DAO. It's a downstream message, but in this update, we are calling it a new message type. And I'll give you some rationale on why we decided to use a new message type based on the discussions we had previous IETFs. So one background, as of now, all the DAOs flow upstream, except for DAO projection, I guess. And this is the first time, and maybe this is the second time now that we have a DAO which is going to go downstream. So this is the primary change in terms of like overall semantics for Ripple. Okay, so this is the primary update. So we have a new Ripple message code. So previously we were setting a particular bit in the DAO message, which said that if that bit is set, the message is going to go downstream. The problem with that particular approach was it will impact the existing implementations. So in the spirit of having new implementations incrementally update their code, we decided to have a new message type, new RPL message code, and it was been brought to my notice that these new message codes are available in plenty, so we could really use those. These bits are really are reducing, it's actually more costly to use these bits than to use a new message code. So we're calling it destination cleanup object. If people here don't like that name, it's free to change. All right, yeah.
I love it. How do you pronounce it? Deco?
Deco, yeah, Deco. I'm not. I was calling it DCO right as of now, but Deco might well as well. Thank you. All right. So these are the rationales. I've already talked about it. Existing implementations do not need to change, and the Ripple message codes are available in plentiful. So, well, you added a new message. Along comes the ACK. And you need DCO ACK also in this context. So in a way, we are replicating things. So I would really like to have some feedback from the working group on whether we add a new message, which I've already done. I've already updated the draft to have a new message. It's still open, but it comes with some package. So now we have a DCO ACK. And one thing that is not mentioned in this PowerPoint is we'll need also the secure version of this. So that is something to be thought about. So if there are any specific comments towards this end, I would be raising this on mailing list anyways. But yeah, if there are any specific comments to this end, really like to take it. Yeah, the next steps. We already had an implementation, but that doesn't count. It's a private repo. The change is trivial implementation wise. It's not a big deal. Yeah, that's all. Any questions here?
Okay, comments? It's very nice that you have running code on that. So it's important.
Yeah. In fact, we have been working towards simulating this at a larger scale. So how it works in 500 nodes, asymmetric links and all this. But regardless of whatever those changes are, or whatever those numbers would be, so the basic criteria or basic design limitation that this problem handles,
I like
that's already there in place. Like you're taking a path which is suboptimal. That's by design. And we want to improve on that. So I can give the numbers actually to this working group maybe next time. Yeah.
In the appendix, you can add the.
Well, sure. Yeah, I can do that. Thank you. Thank you for the feedback.
Thank you.
How many people have read this version of the draft? 1, 2, 3, 4, 5. How are the same people also willing to do reviews of the draft? Who is willing to do a review of the draft? Is Pascal? Yeah. Mamoun? Okay, fine, excellent. Someone else? The more, the better. So it would be nice to have a review and then have feedback on the draft. Are you going to deploy it anywhere? Do you have plans apart from the implementation that also will be in an installation? Any plans about that? Oh, sorry, there is an implementation, but will there be a deployment of the?
Well, yeah, the deployment is, we already have a deployment.
I see.
Which uses this.
Okay.
We already have. So, but we don't have an open source which has this feature.
Okay.
So
fine.
that is what we are working towards.
Okay. Thank you.
Okay, next one.
I'm sorry, I should not call it a deployment. Sorry to interrupt here. It's a pilot. Okay. It's a pilot.
Yeah, but if you can add the resulted performance in the appendix, will be very nice data. Okay, you? Now projection.
So this is a quick update on the DAO projection. Most of the time I will need on DAO projection will be spent on the next presentation. Okay, so I mostly updated the INS section actually to reflect the new modes. Remember that we have now a non-storing mode thanks to your request. And yes, most of the energy that was spent on this was spent on the fast reroute, and I will show you why in the next presentation. So that's about it. The biggest questions we have on this document is not really on the document itself, but on how a controller would get the full topology of the network so as to design all those projected routes. So basically, this document is not a standard document. It cannot live without the help of something to provide the topology. We have a subset of the topology that can be obtained in non-storing mode just by looking at the route, which has all those hops tables. So we have a subset of the DODAG, so we can do some routing there and DAO projection there. But if we want a more generic case of DAO projection, then we would need another protocol or some extensions to REPL to give us more information about the links. And so I wonder if that should be in this document as well, or if it's another document. And if there is advice in the room, then I'm all taking it.
Yeah, Rahul Jadhav Huawei. So I definitely feel that is a different document.
Okay.
Yeah,
are you willing
that
to
would
help build it?
Yes, yes,
Good.
yes.
Okay.
Questions, comments? Okay. Please read it and review it. Okay.
Okay, pleased to see there are so many people. Okay. So what have we seen? We have lots of drafts. Some of the drafts are not going forward. They seem to be blocked, and there seems to be a reason for that. On the other hand, we have drafts which are on the same subject, and I'm afraid that there's some interference, and I should like to see how we go forward. And that's what I wanted to discuss. Do not have high expectations like we're going to solve this today. So what I wanted to know is there is enough interest within this working group to see how we can look at those topics and to present a way forward, such that we have those documents in forward and can see how we go. Yeah, that is the idea. So no solutions, just make sure that we find some people interested to do that. Yeah. So we have here the topics that we have in our charter, and I have used that to annotate where the different drafts are being used about. Next one. Oh, this is interesting. Oh, wait a minute, maybe. Ah, fantastic. Oh, that makes a difference. So we have here the topics. I've separated them in young models, which has had a lot of progress. We have a set of, I think, independent topics, so we won't spend much time on it. Then we have, in my opinion, duck manipulations, which I think we should think what they mean actually for the deployment of the Ripple. And then we have bitmaps and bloom filters, which is a new subject, but for which Pascal has introduced that there are lots of solutions to go forward. So I should like to discuss those. So what is the young models? I think I'm the only one who has written, tried to do a draft, but I'm all alone. And I don't think it is a subject you should do all alone, because it's about modeling and you have to have a vision on how to do it. And the working group RTG area thinks that it's important to have these young models. And I think they are important because once you have deployed Ripple and Mipple, etc., within the field, you like to manage them and get your information and see how well things are going, such that you can sit back. And yep. So who is willing to collaborate on these? It is a bit boring, I know. I tried it myself. But you also need a lot of knowledge, and because you cannot make this model just by looking at the draft and then picking out all the attributes. I mean, that's not enough. You have to know what they're doing actually. So I'm really looking forward to some people who are willing to either collaborate with the Mipple one or me, or to start on the Ripple one, and I'm also willing to collaborate on that. Volunteers?
Rahul Jadhav. So does this also include, sometime back we had a discussion on mailing list about exposing the topology information through some metadata. Does this also include that?
You could include it, yeah. I don't think there's any problem there. It's you have the network. The network has all these servers where all these Mipple things are happening, and so you want to get a good view of what's happening there, such they can make decisions about topology changes, switching off nodes, or whatever. And I think all the information that helps you, even if you have high-level information which is not actually described in the drafts, but you think are very useful, it's there to put in, I think. So you then also have to describe how to measure it. I mean,
yeah.
Yeah.
So yeah, that is something that yeah, because that also has an impact. So in a way, DAO projection also needs to have some information. Right. Yeah. That's what, yeah.
Okay. It's not fatal if it's not being used, but if you think about that your work is going to be used later on, I think this might be very useful. I don't see any enthusiasm yet. Okay, next subject. So we have a set of independent topics. We have use of RPL info, AODV Ripple, which is yours, which I think are quite independent. So they can be put into the stack, and we know that there's a flag day necessary, but it doesn't really affect all the other protocol stuff. Yeah. We have the forwarder select, which is me. I mean, it's also quite independent. I'm alone. I mean, so if anybody wants to help there, then I will be very happy to receive and co-alter. But as long as I stay alone, I don't think it will go forward as it is. And then we have the, I think that's it. So I don't think there's too much discussion necessary about all those drafts.
Rahul Jadhav. So regarding the disk modifications, is there any feedback from the authors?
Not yet.
Disk modification, no.
Dominique?
It is. It's about timing, as far as I understood.
I'm sorry?
It's about timing, as far as I understood, getting the DIO managed, the DSO.
Oh, yeah. Well, so we are 3 authors on this draft right now, and I think Cenk has moved to something else. So we are low on resources to work on that, but we are still interested. So okay. If anybody wants to join and help it moving, you'd be welcome.
But independent of that, it will move forward, you think?
Sorry?
Independent of having additional authors, it will move forward.
It will move forward, but not in the next 2 or 3 months, because I'm super busy.
Okay. Then I think this is a very interesting subject for this group. We have all these drafts which talk about restructuring the DAC. Am I correct in that? And they do it for different reasons, as far as I understood. And there are different results. And so it might mean that there is no coherent view from a user of the network or a manager of the network of which algorithm should be used and what the selection criteria are to be used. I'd like to look at the example, for example, of looking at the connections and how should you optimize the routes through the ripple. So you have these measures and you can have different measures in it. It's clear, you put them in and the network works like that. That's not the case here. So I thought that possibly we might have a draft which tells you how to modify the ducts. So we have a uniform way of handling the duct so that it can be handled. And then we have all the different ways to handle them and eventually decide how they can collaborate in an interoperable way such that the wanted effect is reached. Any suggestions about that? For the moment, for me, they are standalone, possibly contradictory drafts.
Pascal Hubert, I don't see contradiction, at least in the work group document ones.
No, not in the working group documents.
Right. And
no,
so
no.
if we adopt something later, it has to be non-conflicting with the existing work, obviously, or state that is either or, but be very clear on that. And the way I see it is that ultimately, we have done 6550, which was complex enough like that, and we wanted to ship it. So, but we knew there were things missing. And the NP DAO, for instance, is something that we could figure at the time, or just being able to pull some DAOs from selected targets so we don't have to have all the states of the network when you're in storing mode. We knew all those things and we didn't act on them yet, because it will be now a number of small additions, which could be options, for instance, in the final document. What I see is that in the future, we'll probably do a new REPL. We'll take 6550, we'll take all those amendments, and we'll make the internet standard for REPL, right? You see, we'll have to take it from normal standard track to internet standard. And when we do that, just like IPv6 did with 8200, we'll package all those documents which became small RFCs, and we'll write the coherent vision of the whole thing, right? At the moment, all we want to do is do them one by one, make sure they fit well within REPL, explain what they do, and when we do this internet standard, we'll do the packaging correctly. That's how I see it.
I agree with that.
I mean, the IEEE works like that. Every 5-10 years, they do a new, for instance, say 2015-4, right? There is a 2015. And in between, they do amendments, which are small changes. These are amendments.
Let me summarize if I understand correctly. You say we have the drafts, they are on standalone, they are correct, and they describe correctly. It's only during the deployment that there might be interaction which are not possible to be foreseen. And if we want to solve them, we will go to the internet standard stage.
No, it's not what I said. What I said is, as we take them, and we took 2 only, but the other ones are still personal submission, we have no guarantee on them. We expect that they interact without an issue, right? They're designed for that. Unless we were very wrong, they're okay. And we just pick them one by one, make them RFCs. And when we're happy with those RFCs and 6550, and we gather some experience from the field about how they interwork and everything, then we write the internet standard which wraps them together. Okay. And if we found some small issues in the field, then we in the internet standard we'll say, by the way, if you do this with this one, don't do that with that one. But we will take all the text and put it together. Okay,
fine, that I understood. So it's too early now, and we really need to experience to do anything profitable here. That's also what you say.
That's why internet standard is higher.
Okay.
Rahul Jadhav, Huawei. So we're looking, so there are a lot of maintenance activities that have been mentioned. So you mentioned additional topics that we had discussed.
Yes, please. That's what I wanted to see.
So there are a lot of other amendments that we had discussed, but I would say that would the working group be interested in some sort of a problem statement document before we actually start this amendment?
Absolutely, that was the next stage. So I had two worries in this, and the one is the collaboration between the different drafts. I mean, I understood for Pascal and everybody seems to concede we first have to gain more experience, and then if we go to internet standard, that's when we write it up. That's what I understood. Fine, yeah. And the second one is we have all these different treatments which are proposed, and how are we going to get forward such that we have a coherent view on which direction we want to go. And if there are new drafts, then we also can look at them if it fits. Yeah.
Thank you.
Yeah, that's correct. Anybody wants to do a look on that so that we have already this view?
So,
No?
so Pascal, so based on the discussion that we had on mailing list, the topics that were suggested, I would be interested in putting up a problem statements document which talks about those problems specifically. What do you think? Or okay, all right.
Okay.
Right now we are experiencing
Okay.
So basically what's happening, Pascal, again, is that we are experiencing situations in the field or getting requirements from some environments, and we propose solutions for those as amendments to REPL. I'm not incapable to say everything that's wrong or could be updated in REPL and write a problem statement on that. I just don't know. What I know is prime by prime what we're facing. We are facing primes like big DODAGs and nodes wanting to join either DODAG, and we are talking about that at 6 stage. Now we'll bring it here. We're experimenting packet loss when the DAG reorganizes. We want to avoid that. That's the fast route thing. So each time we experience something, we try to come up with a solution which is compatible with what already exists and propose that addition as an amendment to REPL. But it's not like I have a encompassing view of everything that REPL needs, right? So starting with a prime statement, in my view, is no go. We are fixing prime with 6550 right now.
So just having wiki entries, for example, on the role wiki might be sufficient here.
Rahul Jadhav. So I was not suggesting actually a major change to the REPL or anything. So I was suggesting specific amendments given the specific section. An example would be the use of DTSN, the change in DTSN number, and it has to be burned out into the device. So it has to be stored in the persistent memory. Well, that is not practical for my deployment, is what I can say, because the writes to the flash are only limited. DTSN changes more frequently in case of storing mode of operation. And that's quite an issue for me. So things like this, I wanted to bring out to the notice of this working group. Yeah.
Okay, so just a wiki with all these entries and maintaining them will be sufficient, you think? Yep, okay, that solves my problem. Then, oh. Yeah, that's too much for me. Short memory. So then we finally have the CCast, which has been proposed by Karsten, who isn't here, unfortunately. And there has been an alternative proposal for using Bloom filters and bitmaps by Pascal. Pascal proposes that we have different documents. So in one where we... I see your mouse opening. So probably using the wrong words in the wrong order. So.
A bit, yes. I mean, there are a number of things actually which relate to the same world, and you're correctly packaging them on this slide. Yeah. And right today, they are packaged as 2 documents plus an encoding one. Yeah. And I because we had this slide, I proposed a number of solutions. I didn't say we need to have 2 documents. I said we could do this, we could do this, we could do this. Let's propose that to the group and see what the group thinks.
Okay.
Actually, I thought you would put a slide with those proposals.
Yes, that's what I thought. But as I wanted to not to have already the decisions about which documents are going to be done here, but probably discussed later on the mailing list, I thought I should put them forward here. Yep, that was the idea. Is there anyone who is interested in this topic? I thought it might be quite interesting if you wanted to reduce actually the tables etc., and the headers during the routing. So having that and thought was a good subject. Yeah.
Rahul Jadhav. So I'm definitely, I don't know the details of how beer actually works, but I've seen the problem statement and I've seen read the initial. I've not gone through the details of this. The problem statements that it tries to solve are pretty interesting, and it will reduce control over it by a big factor, is what I'm trying to say. But given the fact that there are a lot of things that are there already, in that context, I don't know how to. So you mentioned about splitting combining, mentioning all the functions that these two documents solves, and then proposing solutions towards that. Did I hear it correctly? So between the CCAST and beer,
Okay, so first you got it right. There is there's an encoding which takes a lot less space than full IP address for unicast and mostly multicast operation using bits which point at each individual destination, that's beer. So that you can say, I want to send it to those specific 5 guys just by putting 5 bits in a bitmap and sending to the bitmap. So that's beer. It's as simple as that. Now, those 2 drafts combine in different fashion 3 dimensions. The first dimension is storing versus non-storing, right? So do you route a source route path or do you route to explicit destinations? The second dimension is how do you encode them? Do you encode them as explicit bits like beer does? So you have a fixed number of nodes in your network because that's the size of your bitmap. Or do you express that as a Bloom filter, which I see as a optimization, which gives you some more elasticity on how many devices you can have in the network at the price of more complexity, right? Because you have to do all those hashing and encoding and stuff like that, distribute the hash and stuff. So first dimension, storing, non-storing. Second dimension, encoding of bitmap and versus Bloom. And the third one is I forgot. I had it in mind, but now it's just slips. But anyway, so I must have it in my mail. Point being that you could decide now how you structure the work if we decide to go to it. For instance, do we want to just have, because it's 3-dimensional, like 9 documents, I'm doing storing with Bloom, or I'm, that could be many documents. Or do you say, Bloom is, for instance, an optimization that goes on top of that. It's compatible with everything, all possible nodes, in which case I could say, here is what I do without Bloom, and here is how I Bloomize it, optional. Right. So this is kind of the discussion I wanted to have. Do we want to do storing, non-storing, beer, Bloom, source route versus explicit destination, all those things? Is it? How do you want to structure that? So,
yeah, I got the point. Thank you for that.
Okay. So I think we have had those presentations from CCAST and your presentation on the last IETF. I don't see that there, at this moment there's enough knowledge here to see how we have to go forward. May I invite you for the next in London that you give a 20-minute presentations about all these? Yeah, that will be very nice. I would appreciate it. Yeah, we'll have to talk with Karsten and see. Yeah, I would really appreciate that. That would help. Yep. Thank you very much.
Okay, one comment.
Okay.
The ODB draft, it's in last call. Please review and comment. We need that. Okay, thank you. Who is willing to review? Who read the draft? Okay. Okay. Yes, please, because it's in the last call. So we need that. Your comments. Okay. Thank you very much. Next one. Mamu is going to present load balancing. He merged the documents, right? Yeah. This is the merge of one.
Right. Hi, everybody. Mamu Qasim from Edinburgh Napier University. So this is the 3rd version for the draft, and just a quick hint here, we combined in this draft 2 drafts. The current draft, besides the who from Hawaii draft. Okay, so we already presented this in the previous, in 98 Chicago meeting. So I will skip this and just lift these slides. If you have any question, just to help me to explain. So the new stuff started from this slide, and we added or we amended the DIO by adding in the option part the diagmetric container in order to inject the parent address besides those parameters, and the content of the metric of the new metric. As you can see, those parameters, the flag and the B flag, which is indicates 0 and 1, whether it contains the parent address or not, depends, and I will explain this in the next slide. And the number of direct children for the CNC at the moment, it can be optimized in the future to consider the accumulated number of children, not only the direct number of children. It depends, we'll see that. And the max number of children that can be held, and the parent address optional. It depends, optional or not, based on the mode. As you can see here, if it is in the storing mode, then the number of children can be counted from the DAO, and this is for the upstream, and the DIO just to inform the number of the downstreams, and the proposed options, as you can see at the bottom of the slide. However, if it is in non-storing mode, okay, then the number of children cannot be counted from the DAO, can be done by DIO. That's why we need to inject the parent address in the DIO, and from, where's the laser pointer? No, the laser pointer, yeah, okay. So as you can see here, so this DIO will back to this parent, okay? So by injecting the parent address, okay, the parent can count how many children, okay, has, and in this way we can utilize the DIO, okay, in efficient way to count the number of children. And the proposed rank calculation will be, as you can see from this formula, okay, and the 255, it indicates that this is the maximum number of children can be cannot hold any more number of children. Yes, Dominic, please.
Just a quick comment. Yeah. This is Dominic. In order for this to work, you need to change 5550, because 5550 says you shall ignore DIOs coming from nodes that have a lower rank. So
what do you suggest?
No, I'm just saying the drawing here, you're saying that the parent will receive a DIO from a child and read into that packet and discover that parent address and discover it's being used as a parent. But all these mechanics will only happen if the parent looks into that packet. And right now, 6550 says it will ignore that packet.
Okay.
So just make sure you change 5550.
Thank you. We'll consider that. Thank you very much.
We send DAOs upwards these days. We send DAOs upwards these days.
Okay, thank you very much. So, yeah. And for the sake of the stability issue, actually, here, we can use another metric along with the number of children. So this is not the sole, okay, metric, okay, to optimize the load balancing. And here I want just to highlight very important point. We are not here measuring the accurate 100% traffic. We are here just to optimize the traffic, because this is random deployment and we are not counting. It is indirect. It is indirect measurement. Just we can optimize the traffic as much as possible in this way. Yes, Pascal.
Pascal Thibert, I have a shadow of a doubt. Can you show me the previous slide now again?
Yeah.
Or the one with the rank. So if I have more children, my rank augments. So if I have a new child, my rank will go up. Is that?
Yes. This is,
if your rank goes up, you need to detach from the geodag and reattach later.
well, this is, as I said, the rank for, if we consider the number of children in this for the rank calculation, but we can use the other one beside it. But your question here.
Okay, so it's not the rank, it's something else. That was my question, right? It's not used for routing. Or is it?
It is not, maybe, yeah.
Because if you use that for routing, you will get interesting results, right?
Okay.
Okay, so let me give some background information here, which is coming from 6TiSCH. So for the last 2-3 IETFs, 6TiSCH has been considering some problems we have in the field again, which have to do, for instance, if I have two big geodags or one smaller than the other, and I have this node that needs to join, which of those two geodags, if he sees both, which one should it join? And so it's a problem we have in the field. We thought that there are multiple reasons why a node should join the DAG on the left or the DAG on the right, or the parent on the left or the parent on the right, which is kind of the question that Mahmoud is asking us today. And so what 6TiSCH said is very clearly that the metric that expresses the willingness to be joined by a parent has nothing to do with its routing rank, which is what I want to extract from you and to confirm. Because in one hand, it's how good it is to join this node or to join this geodag. And on the other hand, it's the position of a node within a structure used for routing. Nothing to do. And the other thing is, okay, in the thinking, you need metrics to build this new thing, which is not a rank. We call it a join willingness or something like that. And it looks a lot like the metrics we use for ranks, right? We want to spread them. So an example of metrics is how many packets per second on the route. Because the load of the geodag is mostly expressed by the load on the route, right? So if I have two geodags, whatever their size, if one has twice the packets at the route than the other has, I want to join the least loaded, regardless of the size, regardless of the number of children, grandparents, and family, right? But it may be that in certain situations, the number of nodes in the geodag plays a role because there's management cost. Or it may be that the number of children plays a role. So you see there are a number of metrics which affect the willingness for a particular node to be joined. For instance, how many DIO storage I have to store the DAO in storing mode, right? Stuff like that. So there are many metrics. They are not used for routing. There are different metrics, but we could propagate them through metric containers. That seems to make a lot of sense. And we would like to advertise that to nodes which want to join this parent, which advertises this. So it's next to the rank, but it's used just for the desire of joining. So we are working on that. We are trying to express the metrics we would like to see there. We are trying to express how that could be going down, from the upper layers, the routing layer, where this is understood from the metrics, to the lower layer, all the way down to the beacons, so that it can be expressed in the beacons that you hear where you decide to join a network. So we're trying to look at that, and when we're ready and when we understand what we really want to do, then we probably will come to roll and say, hey, in this overall design that we see, we need those metric containers. Why don't we piggyback them into REPL? We need this in the DIO that has to be put in maybe in EBs or whatever is 15.4. But we are doing this design. It's early in the process. We are not ready to come here and say we want this, if it's your question. But we're getting there. We have a draft Richardson. We have interesting talks on the mailing list. And so we are working on that. The number of children is not, by experience, the most interesting thing, but it's useful in storing mode to decide, how much. If, for instance, there are two parents which are equal for everything else, I would pick the one with the least children. But first, I would pick the geodag with the less traffic. I would pick the geodag which is smaller globally, not just the children of this particular parent. And then, all things being equal, maybe I would look at the number of children. That's one of those things which I look at. So this is work which we are doing at 6-dish, if you want to look at what we are doing and participate to the 6-dish mailing list. And then at some point, yes, we expect to be coming to you, going to IEEE as well, to put that in an IE or things like that. But it really has to do with join, nothing to do with repo. Should not be considered as right.
George Papadopoulos. Pascal, I have a question to you about this. This information you want to propagate at the layer 2 or the layer 3 with the routing? I mean, 6-dish, is it a 6-dish job or roll job?
Okay. What I just said, it's just the same problem as the arrays. At some point, we want to abstract what we see and understand with complex metrics at upper layers into an opaque that we can carry in the lower layers. Because what the node will see is a beacon. So at some point, we want to be able to express some information from the router advertisement and some information like this from the DIO in a compressed, concise form into IE.
So what you want to do is, in fact, to merge EB packets and the kind of DI routing information in one.
Yes, we want to be able to encode some of this information down into the beacon. And that's what this draft Richardson join thing does, join priority or whatever it's called. Because that's a beacon that the device sees. But how we build it is not an IEEE prime. But when we encode it, it becomes a discussion with the IEEE because we want to fit it into the MAC layer flag as an opaque.
Okay, Pascal, thanks. I will take a look on the 6-dish. Thank you very much. Yes, Derek.
Yeah, John from Huawei. So thank you, Pascal, for introducing the work in 6-dish. But I have a question because the scenarios that can be used in 6-dish is narrowed. As far as I know, it can only be used in the industry monitoring. So if you are saying that there is a work done to balance the load in 6-dish, then I think we can say the 6-dish can. It's just like you are solving a problem in a narrowed scenario, but now we are talking about a more right. I mean, now we are talking about the repo. So yeah, you can solve it in 6-dish, but why not solve this in this working group?
Okay, thank you. You have a question? Yeah.
Peter van der Stok, I just want to make a small statement. That is, the stack which is produced in 6-dish can be used in other situations as well, and it works as well. And probably maybe that the restrictions 6-dish are not considered, but in a wider set, it will be very nicely used.
Okay, just
thank you, Peter. And just to say that 6-dish
you.
is the working group where the join is being done, right, for the IoT. It's not because of time-slotted channel hopping. It has to do with the fact that some group had to do the join process. So we are looking at the join process. What is the security of the join process? What are the flows for the join process? We've got two working group documents. What one is basically Anima for IoT, and the other one is basically PSK for IoT, right? So in that context, basically 6-dish is doing it for IoT at large. And as we are doing it, we realize that part of the join process is to select the node that we're going to join. And in that context, which again has nothing to do with TSCH and nothing much to do with 15.4 in general, just the fact that we want to encode it in an IE at the end of the day, we consider what causes a node to be more general, the one you want to join. And the prime I'm addressing, I found them in YSUN, not in 6-dish.
Okay, thank you very much. Okay, so as I said here, okay, So by using a hysteresis threshold, we can just control and the number of children that we can hold for each node based on the application requirements. So you can set up the a threshold according to the application requirements. And as I just want to highlight a very important point raised by Dominique regarding the energy metric container for this stuff. Actually, yes, we could use the metric container for that, and this is the expected balancing after the after using this metric. But for the energy, okay, we can see here there's a congestion, okay, for node 3, as you can see here from this slide. So all these nodes, okay, and I done this by a Contiki simulator, right? So when we have this scenario, all these nodes goes to 3 and left 2 only with 1 child. So now 3, it is congested with all these nodes. Okay, now 3, if we use the energy metric between 3 and 2 to optimize the load balancing, yes, we could do that, but when the energy of 3 dropped or drained or almost very close to die, then those nodes will be handed over to 2. We are trying in this draft to avoid this situation. It's not necessary to reach the threshold of energy for 3 in order to hand over these nodes or the sharing nodes to 2. Okay, from the beginning, once the DODAG, okay, established or constructed, okay, then we have to consider from the beginning this issue to avoid this case. So this is the main point or the key point from this draft. Happy to take any feedback. How many minutes we left? Yeah. Okay. Yes, Dominique.
Yeah, I totally agree. If you want to balance the network, you should use a metric that balances the network. But just one comment back in the situation you described, the node 3 doesn't need to be close to dying for the balance to for the tree to rebalance based on the energy metric, because this is a an 8-bit value, so you can start doing something after a few percent of difference of energy between 2 and 3. And the other thing is, I told you this before the meeting, just because your draft states, I'm doing the tree balancing stuff in order to preserve energy and
to push the lifetime.
So I said, if you want to achieve lifetime, then use a lifetime metric.
Yes, thank you. I will add this in the context of the draft.
Yeah, just state it differently. I want to have a balanced tree.
Yeah.
Okay? Then everything is perfect, and I have no comment.
Thank you. All right. Thank you.
Sorry, I wanted to say something else.
Yeah.
So for the lifetime metric or the energy metric, in some scenarios there could be problems. Like for example, for the Y sound, they are aiming to have a lifetime of 10 years. But if we want to solve this, if we want to solve this problem in 1 day, then we cannot use this lifetime.
Yes. Thank you, Derek.
Pascal, again, if you basically what Mahmoud said, with which I agree, is that at the beginning of times, a node has to join a parent, and it's a join time problem. And that's why we are working on the join time metric at 6-ish. And like I said, there are many reasons why you would want to compute this in a fashion or another. That's how it resembles a rank. Depending on what you want to achieve, you have objective functions to compute ranks. And you need to have some join functions to compute a join willingness, which will depend on which metrics you care for. I take this example. If the guy on the left, node 4, is sending 1 packet per minute, and each of the guys on the right are sending 1 packet per year, I would say that the loaded guy is the guy on the left, right? And it really depends on your network. You have to decide how your objective function works to compute a rank, and you have to decide how your join function works to compute a join willingness, which is what we are trying to express right now at 6-ish.
Completely agree. Yeah, completely agree. Thank you.
Now I remember my second point, which was please do write objective functions that make use of the diagmetric container, because in the past I've seen too many of those just ignoring the DMC. So I like it that
ignoring what? Sorry.
No, I've seen, if you look at the existing objective functions, they just ignore the DMC.
All right.
You know, OF0 says I'm just doing hop count and I don't need a DMC for that. And SFX, well, and Mr. X says I'm going to use ETX and I don't need a DMC. So please do write one that does use DMC. I'd love that as a co-author of that RFC.
All right. Thank you very much.
But no, half joking. In your draft, you say comparing to previous situations, comparing to ETX, etc., we are doing better. But again, I think we haven't exploited the full potential of the DMC yet, because nobody has ever used those metrics. You know, the bit energy, bit whatever. We have a whole toolbox that nobody used before. So I'm glad that you're venturing into that arena.
Okay, thank you very much. The last point, just want to highlight that in terms of the deployment, Derek and Rahul done some deployment stuff in Hawaii. So we are trying to, and they tested it on the smart meters devices. And so we are ongoing in this process. That's all. Thank you. Thank you very much. Thank you.
Just for my information, who has read the draft or this version of the draft? 1, 2, 3. Oh, very good. Okay, thanks. That were about 6, 7 people, I think.
Please take the discussion into the mailing list so we can have in the mailing list that discussion and we can compare with the other 60-ish approach and the metrics that already are available. It would be nice if you can put in the appendix the performance that you have with your proposal and how it will be with this kind of with the metrics that already exist. You know, if your proposal doesn't exist, how can we handle with whatever we have already? It would be nice, compare and see how is the performance with the comparison. Okay, thank you. Oh, no. Is that where we go? Sorry. No. No, it's that one. No. Wait. Okay, sorry. Giorgio? He's going to present the new work proposal.
Hello, everyone. My name is George Papadopoulos, and I'm going to present a draft that I wrote together with my colleagues, Aris, Nicolas, and Pascal Hubert. And the topic is related with the extension of node state and attribute. Thank you. So to go a little bit to the context, we are working here in the area of deterministic networks, where the networks, in addition to be reliable, they need to be deterministic as well, meaning that to reduce the jitter to minimum. To do so, one of the potential solutions is the packet replication elimination. And the concept of PRE is about each node to transmit each single data packet will transmit once to his default, what we call ripple parent, and to his alternative parent. This is the replication procedure. And then on the other side, when a node will receive multiple copies of a single data packet, he will eliminate the following copies to reduce the unnecessary traffic. Then in addition to what can be applied is the promiscuous overhearing procedure, meaning that when S transmits to A node, then a symbolic node of A may overhear this information due to the nature of the wireless medium of the broadcast. Then, and vice versa, when S will transmit this information to its alternative parent, A may overhear. Like this, we increase the probability of this information to be reached to the destination. So in 60's working group, we wrote what's called requirements, set of requirements to have a PRE to be implemented and to work correctly. And some of them are the how to select the alternative parent selection and what are the requirements to do for this, about the promiscuous overhearing, cells without acknowledgement, since you are transmitting and one will acknowledge, the other overhearing node will not acknowledge. These are things to be discussed, and the packet elimination issues. So in this draft, we focused on the in the first item here on the alternative parent selection, but not specifically how to select the parent, rather than how to extend this DIO information, DIO message, so that to provide information regarding the parent node set, what we call. To go a little bit to the details before going to the examples. So basically, one potential way to select an alternative parent is to have common ancestors. So potentially your default parent from the REPL and your possible alternative parent, if they have somewhere in the REPL DODAC common ancestor, you may consider this as alternative parent. So this is one of the solutions that can be done, right? I mean, this is not the what we propose here. But in order to do so, we will need to extend these DIO messages, right? So, and this is what we've done here. So this is the DIO format example, and we are going to focus on the DAC metric container type here with these different options that they have, and then we're going to the options field. And what we did here, we went to the this routing metric container type. We pick up the one which is for the node statement and attribution. And we added a new TLV type, and we call this PNS, parent node set, so that the node will transmit set of information, set of IP addresses of each potential parent node set, right? So each node within this DIO message will forward down to his children what is his parent set node. Okay, so this is what we did here by adding set of IP addresses to this DIO message. And here I will give you an example. Considering this simple topology, this is the source node, these are the relay node, and somewhere up is the DODAC root. So S has its default parent A from the REPL, A has D, and B has E as a default parent. Then what happens is that A may have, in addition to A, which is default, a parent set B as a potential as a node within his parent set node, right? So potential parent. And similarly, A has his default parent D, which is here underlined, and CE are his included in his parent set. Finally, we have node B, which works in the same principles, has his E as default parent, and D is part member of its parent set. Now, what we do here is, by default, we are having this DIO message that transmitted within this REPL operation. And every time when A will send this DIO message, he will include within the DIO metric container and say what we call TLV, what the TLV that we call here, that we define here, this parent node set. So A will say, S, look at here, my parent sets are C, D, E. And the same way, B will say within his DIO message, A, S, or whatever, whoever is in his neighborhood, I am B, and this is my parent sets, D and E. Now, when it comes time to S to pick up his alternative parent, he will check, okay, this is my default parent from REPL, right? And D is a default parent of A, so this is my direct grandfather, what we call it. And then, since I received the information from B as well, and I can check that D is within the parent set of B, okay? So what we're trying to construct here is the ladder-based, or DNA, what Pascal calls topology. So at the end of the day, we are having one common ancestor between A and B, which is the grandfather for S. So then S will pick up as an alternative parent B, and the same way we have for the other guys. So A will have his own D as a default, and some alternative will be C in the same principles, and B will have, again, E through ripple and D through our DIO message that we constructed here. So this is to summarize that we are having the default parent and the alternative thanks to this DIO message, which we implement this parent node set TLV within this NSA object, and we, as a result, we are able to pick up our alternative parents in order to employ packet replication elimination procedure. So again, note that this is small part within the larger scope of packet replication elimination. There are more works to be done. And yes, we implement this in Contiki OS. And yeah, some questions further. There are like volunteers to review and yeah, to their elements in the role working group.
Rahul Jadhav, can you please go to the previous slide?
Sure.
So node D is the common ancestor at the same hop as A and B. It is mandatory to have.
I'm not following. Can you repeat again?
This node D is a common ancestor for A and B. It has to be on the same hop for this to work, right?
So node D is common ancestor for
A and B.
Voila. Yes.
Correct. And it has to. So if there is no common subset, then this won't. Then there is no way to identify. Then there is no way to do packet replication here, right?
Yeah.
All right. So one more thing is, in case of high densities network.
Yep.
So there is a limit on how many parent set, how big parent set you can send.
Yeah, that's true.
So during experimentation, you might have came across this problem.
That's true.
Yes, how you're perfectly right. Doing this in a distributed fashion is harder. So that's why if we can manage to do this centralized vision of the topology, we can do a lot better job at this from a centralized perspective. But this is the way we can do it decentralized.
Yeah. So ideally for packet replication, the best way to have, I mean, I don't know the solution here, but the best way to have is have a complete disjoint path all the way till border router. If somehow that is that possible?
It's a lot worse than that, Pascal. Again, what you see, I mean, George just did not have time to tell you the whole story. Okay. There's a big story. But part of the story is you don't want, in wires, what you see is correct. But we are doing wireless. We have a lot more loss on each hop. But yes, when B sends to E, you see this green arrow. D can be this name. And so you balance the loss that you have on the direct path with redundancy on the alternate path. So you really do PRE at each hop.
Yep. Yep.
No, because you eliminate the packet. So you wait for the 2 copies and then you send out.
I have a draft. I have a draft in 60's working group which details all of these steps, like elimination, replication.
To understand the full things. It can be very powerful. Because I was talking about multicast yesterday with Peter, and this is the same idea applied to unicast, but using multiple things at the same time to increase reliability for the exact same reasons that you were advocating yesterday. So that's what we are doing actually with this thing. If it's centralized computation, we also practiced it. It works really well, and we have like the delivery ratio within due time, which is critical for determinism, becomes good. I need to mention to the chairs there is IPR behind us. There is IPR behind us. Like everything else.
Can you send to the mailing list? Can you send to the mailing list?
But there is IPR? I think it is, but okay, I don't know.
You did only for the 60s. You said in the 60s.
Probably
Anyway, it could be announced, or it doesn't announce the mailing list, but since you mentioned for 2, I wanted to make sure. But everything is done. So it must be very sure.
I have 2 questions. I have 2 questions. First one, how in this topology?
Please, your name. State your name. Your name.
Hisham al-Bakuri from Huawei.
Thank you.
How in this topology you can eliminate replication?
So the idea is, this is one of the requirements, right? I'm going back again. We need to tag in each packet the sequence. So when you're going to when you're sending the same data packet, like S will transmit this information to A and then he transmits to B, there's a tagging which we're supposed to do it, right? I mean, this is not written in a draft, right? So the idea is there will be tagging in each packet. Then when D will receive first from A, depending on the scheduler whether A transmits first or B, we are going back to 60s. Then since D will receive first from A, he will check again the packet, the consequence reception from B, and he will eliminate this information from B. So he will forward only the information received from A.
But you still B sends the same packet to D.
Excuse me?
So you still do replication.
Yes, until to the common
At
ancestor.
the point where you can eliminate this.
Voilà.
But we had the same issue in .NET. And I would think maybe using some techniques like network coding, you can eliminate replication. So
At Mike, please.
Okay, so Esham was telling us that network coding works there too. And yes, I mean, what we are doing now is topology. We are building a topology which enables replication and elimination, which is one way of doing redundancy, and network coding is another. Basically, see this as a form of flooding. We built something which looks like a ladder, you see? And now you flood it. And it's normal flooding. When you flood something, you see a second copy of what you already flood, you discard it. There are tons of history on how you do flooding and how you eliminate the duplicate copies of flooding. You can do basic flooding with the original frames. You can do network coding. You can do anything you like. The problem we have here is just to build a structure, a limited number of links on which you will apply those techniques. And so it's orthogonal to the fact that you decide to do network coding 1+1 redundancy or redundancy at every hop, etc. That comes later.
Thank you. You asked some questions at the end. Not yeah.
If it's answered, yeah.
Yeah. Okay.
True story. Yeah.
Well, this is a very good question. Who has read the draft? It's originally a 60s draft, but who has read it? Okay. So, having heard the presentation, are there any people interested to review it, to work on it? No? No, I'm happy to review it.
Thank you.
Thank you. Yeah. Two. Okay. 3. Okay. Fine. The subject is within this group, and it is within this charter. So,
great.
Let's talk about it in the mailing list. Okay?
Great. Thank you so much.
Okay, so earlier we discussed about beer for REPL. Okay, sorry, thank you. We discussed about SDN for REPL with the DAO projection. We discussed beer for REPL. Now we just discussed .NET for REPL. So maybe it's time to discuss fast reroute for REPL, just to make sure we've got the complete picture. Okay, so let's talk about fast reroute for a minute. So what the problem is, so you've got this DODAG here that you are lucky you can see, but I can't. And things happen normally. So I have isolated this node here, which had a single parent, bad luck, and that happens in DODAGs. And this guy loses its last parent. So that's when you enter this phase in REPL, whereby you have to reparent to a node which is lower than you are, which means you have to go through all those poisoning or freezing thing, which is the pain of any distance vector protocol. So basically, you have to isolate a number of nodes which are impacted by the fact that you lost your parents. Basically, all the nodes which didn't have much solution but you to go to the destination, and you have to freeze them until you have reparented, of one of them has reparented, and you can find a new exit path through them. And the problem is, with REPL, it's going to take some time, because you have to poison, wait for the resulting of poisoning, and then look at where you are. And when you know where you are, you have isolated all the impacted node, then from there you can rebuild something. And the problem we have at 60ish, because we are building some networks which we want very reliable, is that sometimes we can't afford to lose this packet, and this window of time for the distance vector to reconstruct a new path is too expensive. So we are looking at doing fast reroute, which is this technique by which you go around the problem to a point where the problem is no more. So you have to find a way to go back, maybe, or tunnel somewhere to a point which is not affected by the disruption. That's a generic thing that fast reroute does. So that's why we have these header insertions that are being discussed at 6man, you know, which does source routing to that point where the prime is avoided, for instance. Okay. So that's pretty much the problem. How can you keep forwarding packets and possibly find a new parent which does not create a loop faster than just waiting for the methods that Ripple has today? So there are basically two approaches that we have been discussing at 6TiSCH. And so I'm presenting them to you, and we will see what could be done within ROLL if we decide to take this path. So the first thing that we looked at is whether well, there is a zero thing actually, but Simon is not there with us. Simon is claiming that in most times, I mean, the loops that Ripple creates by attaching lower, the packets can stay in that loop till the new parent is found, and sometimes the packets are not yet destroyed and new parent is found. So he said that sometimes that saves the day. We can't claim it saves the day every time, but it may happen, right? So we don't lose every packet in those situations. Some are caught in a loop till the loop is resolved. But that's when it's very slow, when there are very few packets. Right? So apart from that, the sort of thing we've been looking at two approaches. One is the current thinking of Ripple is to do things in the data path. We already have this Ripple packet information in Ripple, which allows you to detect that there are some routing errors. We've got like 3 flags in the RPI that allows you to know if there is DAO route or not, or if your packet is going down when it should be going up. And so you have an inconsistency, and based on this inconsistency, you can repair. So we already have some data path information in Ripple, which triggers the routing, but which detects the error. So we thought, hey, why don't we use the data path to see whether by exploring my children, I effectively find a path to the root, which avoids me to wait for the freezing, with the risk that I choose wrong the child, but then I detect it, I eliminate it, and I take the next child. See? Basically, rather than waiting to be sure that this child is usable, let's try to use the children we have and see if that creates a loop. That's pretty much the idea. If it does not create a loop, then I can reparent to this guy, and I'm all set. So the first, and there are two sub-approaches to that. The first is on this screen here. And it basically says, let me put a new bit, and we have 1 bit left in the RPI, so that's okay. Let's use the bit to indicate that we are sending the packet the other way, that we are sending the packet down. So if we see it again, it means we sent it to the wrong child. Let's not use that one. So basically you pick a child, whichever, and you say, let me see if that child, that guy, it's not necessarily a child, that guy is my child. If he's my child, it's going to loop. If it's my grandchild, etc., it's going to loop. But if it's not my grandchild, if it's just somebody lower than me, but not my grandchild, then it's not going to loop. He's a feasible successor. I can reparent to him rapidly, right? So you want to discover that situation. So what you do is you effectively tag the packet, say, oh, that packet went through me. And you select one of those guys, and if you see the packet coming back, then this guy cannot be used. Let's pick another one. And it's just a little trace that you place in the packet. Okay, so that's basically, you see how the approach works. Rahul?
Rahul Jadhav. So, but how does the parent know that the P bit was set, or any flag was set by itself?
It does not. It will just drop the packets when they come back. He may actually. Basically, the idea is you expect only one breakage, right? So you're the one in front of the breakage. You expect there is not another breakage which is being fixed at the same time. If there is, too bad for the guy below. But the point is you want to solve. It's just something to try to do something faster. I'm not saying it solves multiple breakage at the same time, etc. You expect one localized one breakage. So you just pick one child and you try it. So you send frames. And if you see one of those frames coming back, you say wrong child. Otherwise, you keep sending your traffic there. And if it's an okay child, your traffic will effectively go to its destination with the bit out.
So in the same context, but if there's a genuine drop somewhere,
sorry,
drop of that packet.
If that packet is dropped, you don't see it. You will send another packet. If that other packet comes back, then you know it's wrong child. But maybe after the life of the packet is what it is. It's just that this packet will live with this bit on. So if there is, as you said, because you isolated the prime correctly, if there is another breakage later, the second guy who sees this packet may think he is the one who set the bit. And in that case, it will discard the packet and say, I picked the wrong child. So there might be a confusion if there are two breakages at the time, and the next slide will solve it. So I don't want to spend too much time. Charlie?
Well, maybe I should wait for the next slide.
Okay, so this is, Mahmoud, do you want to talk on this slide?
Just a bit of question here. The picking the child based on what? Randomly?
Yeah.
And for how long?
Oh, well, till the freezing solves.
So there's a certain timer?
No, it's just that Ripple will solve this eventually.
Okay.
It's just that there is a short window of time till you reparent, where you don't have a parent. You're in this situation where you're looking for a parent, just like looking for a job. And during that sort of window, you should drop the packets. But rather than dropping them, you say, hey, let me hope and pick one guy who is lower than me, because I see nobody higher than me. So let's pick one, flag the packets as being tentative. And if the packets come back, think that it's me that set the bit, and say the guy to whom I'm passing the packets right now is not a good guy. Let me pass the packet to somebody else.
Oh, okay.
Right. It has a number of drawbacks. I just wanted to mention it. Right? It's very hard, for instance, when you switch and you see a packet coming back, it might be one which went through the old path. So there are a number of little Windows race conditions which are not too clean. But it's just to mention that gives you an idea of the sort of thing we want to do in this type of case.
Just to optimize the selection, why you couldn't, rather than keep it randomly.
Optimizing the solution could be pick the lowest rank, because
Yes.
that's the guy which, if first the lowest rank would be if it's a child, then it's probably a direct child. If it's a direct child, then it will just send you the packet back. You can eliminate it. That's what I drew. It's only when you have to dig deeper than you may have a grandchild, and it's harder. Right. So, but the normal case is you pick somebody with the highest rank possible. And yes, if that's what you wanted to, yes, you're right. Blah blah blah. So that's it for the very basic idea. Now that is just using the existing traffic, and like we discussed, it's no drawbacks. The alternate is to generate traffic, to send a probe that you generate yourself. So now you know it's yours because your source address is yours, right? And basically what you do is you ping the root via a number of selected other guys. So you pick like those 3-4 guys with the highest rank that you can still see, and you send a packet to the root, and you see if it comes back or if the root responds. If the root responds, you're very sure that this guy is a feasible successor. He can reparent. If the packet comes back, well, you eliminate this guy from your list and you pick others. See, so that solves a number of the problems that we have just seen in the initial case, but you have to generate new traffic. And so it's basically an explorer of all the guys behind you to see if one of them is actually not parented via you. And if one is found, then you just switch to him. And then Ripple will, so you went down, maybe you went down too low, but now Ripple will allow you to go back up, right? And well, that's it. And then Ripple, as you go down, so some other node will decide to stay with you or move elsewhere, etc. That's normal Ripple operation. Okay, that's basically what we could do in. So Charlie, do you still have a question, or I see you?
Well, I was sort of waiting to see if you would answer the question, but it seems like to me what you have is a design whereby you're going to sort of eliminate potential other neighbors one by one and see until you find out one.
Well, the first method, yes. The second is just you select a few of them, you ping the root through all of them in parallel. So the second one is not one by one.
Oh, so this is a sort of a.
This is when you ping the root.
Okay.
So you could
multicast ping or something.
You could create a ping, multicast, a big word. This is a series of unicasts, really. So you just I have four guys, which I hope one of them is feasible. I just ping the roots through all of them. Pang, 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 pang. And the ping that comes back from the root tells me that this guy is useful. I can use any of them till I don't know better. The first packet that comes back to me without going to the root, I eliminate directly. I can still use the other. And the first which comes back from the root now tells me, oh, this one is definitely feasible.
Well, you could almost accomplish the same thing just by requesting a route to whatever destination you want, and then.
By what? I'm sorry?
It seems to me you could pretty much accomplish the same thing by saying, I want a route to a particular destination, and if it gets back to the route, well, the route is likely to have a route, but if it gets back to
you mean storing mode? Yeah, I mean, I don't care what the message is. In non-storing mode, any message to any destination would pretty much get that.
We still have 1 minute. We have to conclude somewhere.
So
I'm sorry to disrupt you.
Yeah, but
so the solution is only for non-storing mode?
No, your solution would be only for non-storing mode. Mine works in any case. By pinging the route, I'm sure that I'm going higher than I am. If you knew by heart somebody who's higher than you are, then you could do, okay, you could ping your previous parent, and that would work. But I don't know if it's much better. Maybe it's more costly. So if we are optimization space, we can discuss on the mailing list, like Peter said.
Okay, but it's nice to have pictures in the mailing list usually. Anyway,
okay, and we can talk outside.
There are still a few days left here.
That just gives you ideas on how that can be done in the data plane. I'm not saying it's a final solution. I'm just throwing ideas at you, right? And the other one, which is more of impact to us, is basically to apply centralized computation and probably ARCs to compute plan Bs, in which case the DAO projection draft is impacted a little bit.
Thank you very much.
That was good. So please go through the slides. We probably will do them next time. And I'll be glad to come back if you invite me.
Yep. Always will be happy.
So we discussed the data plane, and there is a routing, forwarding, the routing plane, control plane solution, which can do the same thing, and we'll discuss it. But it impacts DAO projection. That's why we're here.
Good. Thank you very much.
Okay, we are running over. So thank you very much to everyone. Please keep this discussion in the mailing list, and
I think we will continue, and we certainly have to maybe organize a discussion session next to the normal role meeting. So we have the role meeting where we present the current drafts, and we may have a discussion meeting where we discuss all these subjects so that we can come to a common conclusion. There is that possibility as well. Yeah, but look here, you look at the mailing list, nothing happens. And then we say, oh, 1 hour will be much too much. And what happens? It fills up. So, yeah, no, there's that problem as well. Yeah. Yes.
Thank you very much.
You didn't conclude?
Thank you. It's been a pleasure.
I want to capture interest, and if interest there is, then I could write it.
Because when we did the draft, we did the draft.
I did that on you.
Yeah, but there is this card that I hope.
Yeah, but you know, I can. It's always a long time to write a 0, and then if nothing happens on it, like there's a no. Yeah, I went through 2 times, right? I mean, I tried both. It's not that I don't want to. But this one is much harder to write. So the bits that were the following things are quite easy. The second piece, well, there's a change in the projection. It's small. It just says, oh, now you can say, because what you can't do in the projection is, if you are my parent, this link is always